In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds? They're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the sun. Venus, for example, has a retrograde rotation, which means that the sun rises in the west and sets in the east on that planet. So now when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep. Some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the Sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well, because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped. and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between half an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangaea, Pangaea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangaea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangaea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangaea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangaea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the Sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
What if I told you that humans could have evolved on a planet other than Earth? And we're not talking about Mars here. This planet is Venus, one of the most toxic and dangerous places in our solar system. But imagine this. Once upon a time, Venus was a happening place for potential life. And maybe, just maybe, life was there. How is that possible? And what happened? Let's figure it out. Picture this, a planet swathed in clouds and named after a deity of love and beauty, Aphrodite. Sounds enchanting, right? But don't be fooled. Venus, our neighbor, is the second planet from the Sun, and it's no picnic. Its surface is hot enough to melt lead, and the atmosphere is so thick that the Sun is just a blurry smudge. As you get closer to it, things turn from dreamy to downright hellish. About 30 miles up in the atmosphere, temperatures range from 86 to 158 degrees Fahrenheit. And this is just the beginning. To survive on Venus, you'd need super-duper insulation, because temperatures can reach a sizzling 900 degrees Fahrenheit. Plus, the weight of the atmosphere would bear down on you like being submerged deep in the ocean. The atmosphere is mostly made of carbon dioxide, and down at the surface, it behaves in a corrosive way due to the intense heat and pressure. The sky is sulfur yellow, and the clouds are composed of sulfuric acid. The surface is filled with active volcanoes and craters. Yikes! It's like the environment itself turns against you. Venus is often referred to as the Earth's twin. That's because Venus is almost as big as Earth, just a tad smaller, and these two planets look quite similar on the inside. But in reality, Venus is more like Earth's opposite than its twin. It spins in the opposite direction, has longer days than years, and has no seasons to speak of, not even mentioning its crazy weather conditions. But believe it or not, it wasn't always this way. A long time ago, around 3 billion years after it was born, Venus might have been a watery wonderland like our beloved Earth. It had a cozy climate, and researchers think there was even enough time for life to emerge. But how do we know that? Back in 1978, NASA's Pioneer Venus spacecraft discovered hints that Venus might have had oceans on its surface. Since then, scientists have sent more missions to explore the planet, and they've learned some fascinating things about its past. NASA researchers have come up with 5 cool simulations to show what Venus was like with different amounts of water covering its surface. To create these simulations, scientists used a fancy 3D model that takes into account the gases in Venus's atmosphere billions of years ago and how they are now. They also considered how the sun's radiation has changed over time, getting warmer as it ages. And it turns out that Venus used to be a lot like Earth. All simulations suggest that Venus could have had stable temperatures, ranging from a comfy 68 degrees Fahrenheit to a toasty 122 degrees Fahrenheit. In some of the simulations, Venus had a similar landscape to what it has now, with a shallow ocean and some water trapped in the soil. In others, they imagined Venus having a deep ocean or even the entire surface covered in water. Surprisingly, in all these scenarios, Venus could have maintained temperatures suitable for liquid water. Now, imagine a parallel universe where Venus stayed this way. What if things turned out differently and it was still as cozy as Earth? It could have been the perfect place for humans. Its oceans would have provided a nurturing environment for life to flourish and evolve. The temperatures would have been like a perpetual springtime picnic. Can you imagine lounging under a Venusian palm tree, sipping Venusian lemonade? Ah, the good life. Also, Venus had a slow rotation compared to Earth. Days would have stretched out, giving us more time to enjoy life's simple pleasures. Instead of 24 hours, a Venusian day might have lasted for months. You could have taken an extended vacation and still had time for a full makeover. And what about the higher atmospheric pressure? It may sound intimidating, but it could have actually worked in our favor. The higher pressure would have provided a cozy and snug environment, like being wrapped in a warm, fluffy blanket. No need to worry about the chilly winds of other planets. Venus would have had us covered. Oh, and remember the acidic atmosphere? It may sound strange, but it would have had its benefits too. Venus would have been a carbon dioxide-loving paradise. Plant life would have thrived, creating lush landscapes and filling the air with fresh oxygen. So in this scenario, Venus could have been our haven among the stars. So what happened? What has ruined Venus? Unfortunately, everything changed about 700 million years ago. There was a huge event that caused Venus to change completely, turning it into the hostile place it is today. It experienced a runaway greenhouse effect, which made its atmosphere super thick and scorching hot. A runaway greenhouse effect sucked all the water into space, leaving behind a scorching surface of volcanic rock with thick, crushing atmosphere and acid clouds. Yikes. So what caused this catastrophic transformation? Well, our experts believe it may have been due to volcanic activity. When magma and molten rock reached the surface, they released a bunch of carbon dioxide into the atmosphere. If the magma cooled before reaching the surface, it created a barrier that prevented the gas from being reabsorbed. Massive amounts of gas were released into the atmosphere. Something similar happened on Earth with the Siberian traps, which caused a mass extinction. Venus had its own mega transformation. So, unfortunately, this catastrophe changed the history of our solar system once and forever. But here's the fascinating part. This little mysterious planet still could teach us a lot about the origins of life. For example, if Venus was once habitable, it opens up exciting possibilities for exoplanets in the Venus zone of other star systems. Maybe they could support life too. There's also a critical question that scientists ponder. How do these life-friendly worlds come into existence? Early on, Venus and Earth were strikingly similar. They were close in size, had similar structures inside, and even had oceans in their youthful days. But one planet turned into a scorching inferno, while the other became a thriving hub for abundant life. Why is that? And finally, believe it or not, we can't completely rule out the possibility of life on Venus even now. Up high in the thick yellow clouds where the temperature, air pressure, and chemistry are friendlier, there might be a chance. That's a range where earthly life, like tough extremophile microbes, could potentially survive. The atmospheric pressure up there is similar to what we experience on Earth's surface. We've even noticed strange dark patches in its atmosphere that come and go. Dark streaks persist, defying hurricane-force winds and absorbing ultraviolet radiation. Scientists are scratching their heads over these persistent streaks. They suspect they could be made of fine particles or ice crystals. But here's where it gets wild. Astrobiologists consider another option. Could these streaks be made up of Venus-style microbial life? They theorize that ring-shaped sulfur compounds in Venus's atmosphere could act as a protective coating for the microbes. Wouldn't that be amazing? That's why, by studying why Venus went down a different path in terms of habitability, we can unlock the secrets of what makes other worlds just right for life. However, there are still mysteries to solve. We need more missions to study Venus and understand its history better. For example, learn how quickly it cooled down after its formation. We also want to figure out if the transformation was a one-time cataclysm or a series of events over billions of years. Nonetheless, we can still dream of the Venus that could have been. A paradise where humans and Venusians could have lived side by side. So keep your eyes on Venus. It's a wild planet with a captivating history. Who knows what other surprises it has in store for us? Let's keep exploring and reaching for the stars.
Hey there! Imagine a place on Earth that's just like Venus. It's Chile's Atacama Desert. I assume you wouldn't want to spend your holidays there. Similar to other deserts, this one isn't exactly the friendliest place. It's a long stretch of land close to the Andes Mountains. This makes it one of the driest spots on the planet. In fact, it's so dry that only a few places in Antarctica have stayed without rain for longer. This tough environment has some benefits to offer. Because it's located high up and doesn't have many clouds or a lot of light pollution, it's become the perfect home for advanced telescopes. These telescopes help us explore the cosmos. A new study from June 2023 revealed that this desert is even weirder and more out of this world than we had thought. It makes sense that a desert as dry as this one gets a lot of sun. On average, it has about 308 watts of sunlight per 10 square feet. That's almost twice as much as places like Europe or the eastern United States get. Raul Cordero is a scientist. He and his team checked out the sunlight in the spot housing the biggest telescope project ever, the Atacama Large Millimeter Array. And this is the sunniest place on Earth. This is what you'd experience if you were about 79% of the way from the Sun to Earth. Of course, if you were actually on Venus, you would have way bigger things to worry about than just a lot of sunlight. Now let's figure out why this place is almost as sunny as Venus. It's because of clouds. Usually, clouds block sunlight and keep us cool, but sometimes they can act like a magnifying glass in special situations, concentrating the sun's rays. This is called forward scattering. This happens when certain types of clouds show up during the South American monsoon in the middle of the summer. During the summer in the southern hemisphere, we're actually a bit closer to the sun, and there's less ozone in that part of the world. This combo might explain why other high places on Earth, like the Himalayas, don't get as much intense sunlight as this desert. Let's talk more about Venus. What would it be like to stand on the surface of this planet? The more you learn about this sweltering world, the less you want to picture yourself there. It's not a friendly place at all, with crazy heat and super heavy air that could crush you. But pretend for a moment that you're on Venus. The air there is thick and heavy, 93 times denser than what we have on Earth. The air presses you down. Think of having a small car resting on your thumbnail. That's how it would feel. Or think about diving really deep into the ocean. You'd feel a lot of pressure pushing on your body. But on Venus, it's like having all the pressure of the atmosphere squishing and almost flattening you. What is the weather like on Venus? Ouch! Heat. Even though Mercury is closer to the Sun, Venus wins the prize for the hottest planet's surface. That thick air on Venus is mostly carbon dioxide, which acts like a blanket. When the sun shines on Venus, the heat gets trapped by this blanket of air, and the planet heats a lot. Temperatures on Venus can hit 860 degrees Fahrenheit. Now, how do we explore Venus without getting roasted or squished? Well, going there in person is a no-go. Robots can handle it, yet even robots have struggled on Venus. Only a handful have made it to the surface. And they only managed to survive for a few hours before getting wrecked by the harsh conditions. The good news is we're figuring out ways to study Venus without putting anyone at risk. Future missions will check Venus out from above. Spacecraft up there will be able to see through the atmosphere without any trouble. NASA's got the Veritas mission. Its aim is to make detailed maps of Venus from orbit, giving us a new view of the place. So we've examined the driest desert on our planet, the Atacama Desert. No wonder this area is the place that serves as testing grounds for space missions. But despite how arid this region is, there is life there. This is a realm of flamingos and lagoons. The place has colossal salt flats that extend for 4,633 square miles at a depth of 82 feet. It's a place of erupting geysers, naturally heated springs, towering volcanoes, herds of llamas, and deserts so parched that certain pockets have remained untouched by rain for over half a millennium. All this unfolds 2 to 3 miles above the sea level. What else survives in the Atacama Desert? It's quite hard to fathom that plants could thrive in such inhospitable conditions. Yet, they managed to survive here. Take, for instance, Tillandsia landbecki. These plants defy the odds in the desert by extracting moisture from the fog that rolls in from the nearby coast. This fog water can also serve as a sustainable water source for humans. These plants lack traditional roots. Instead, they use their older, deceased parts to anchor themselves in the sand, forming little dune-like structures. They draw moisture out of the mist through their slender leaves and shoots, which swell upon contact with water. Nocturnal dew also provides water, particularly during the summer when fog is scarce. Together, plant communities existing there are known as lomas vegetation. The presence of this vegetation in the Atacama Desert is limited to a narrow coastal area where fog regularly occurs. Factors such as the distance from the Pacific, prevailing wind direction, and topography restrict the distribution of fog ecosystems. Satellite data analysis reveals that plants grow at altitudes ranging from 2,625 feet to 4,100 feet above sea level and up to 28 miles inland. They are mainly found on sandy plains along fog corridors or on slopes. They're about as tall as 1.5 feet, and they usually form a line. This clever lineup helps them catch all the moisture and yummy nutrients they need. The arrangement of these clusters depends on how much foggy water they can find. These tough desert plants are like water wizards of the plant world. They're so good at surviving in the desert that they give us ideas about getting water from fog. Water is precious in places like Iquique and small villages near the desert. Plus, with all the digging for stuff like copper and lithium, which makes batteries work, they need even more water. Usually, people get drinking water from under the ground, but these little plants have something to teach us. Using this trick, we're making a map showing where these plants like to party most. This map could help us find perfect spots for catching fog with special nets. Here's another idea that will make you feel like you're on the surface of another planet. Pelican Point is in Namibia. You might not expect it, but Pelican Point is actually a great place to surf. Every year, it only gets around 0.30 inches of rain, but that doesn't stop surfers from riding the waves. The weather is kind of unique here. It's hardly ever too hot or too cold. This place has an unusual type of dry climate, thanks to the cold ocean currents near the bay. Skeleton Bay, alternatively named Donkey Bay, is an iconic surfing location. The surf wave crashes onto the sands of Pelican Point, situated about 5 miles northwest of Walvis Bay, a compact harbor town famous for its sand dunes and secure anchorage. Would you surf there?
So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and we are, the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover. Pluto used to be considered a major planet, but later was reclassified into something called a dwarf planet. Something too big to be an asteroid, but too small to be taken seriously. How rude. But recently, scientists began to discuss the mystery surrounding one of Pluto's moons. It turns out, it might be even cooler than all of us. It might be a double planet system. Pluto is residing in the distant Kuiper Belt. It's a vast area in our solar system, like a big rocky suburb beyond the orbit of Neptune. It's filled with small icy objects, similar to Pluto, called Kuiper objects. They're leftovers from the early days of our solar system and give us clues about how it was formed. It's where many comets come from. You already know that it's small, but it's remarkable just how small it is. Pluto has a width of about 1,400 miles. It's about half the size of the United States and smaller than our moon. Pluto's atmosphere is very thin and composed of nitrogen, methane, and carbon monoxide. Stinky. It's also very cold there, with average temperatures being around minus 390 degrees Fahrenheit. Its orbit around the Sun looks like an oval, and 1 year on Pluto takes around 250 Earth years. Pluto also shows a strange and unusual retrograde rotation, because it's tilted on its axis, which means that it spins on its side. If you were standing on Pluto, you'd see a lot of high, icy mountains, valleys, plains, and craters. The sun would be very dim and far away, and it would always look like twilight. It's a colorful planet, surprisingly. You would see a rainbow of pale blues, yellows, oranges, and deep reds. And the most adorable fact about Pluto is its famous heart, called Tombaugh Regio. Pluto was discovered super late in the 1930s, later than the rest of the planets. Initially, we thought that it's the 9th planet in our solar system. However, the more we explored the Kuiper Belt, the more we realized that it's full of these medium-sized objects. We found 4 more little planets just like Pluto: Eris, Ceres, Makemake, and Haumea. They all shared the same characteristics. And that's where we figured out that Pluto belongs to another family and created a category of dwarf planets. There are a couple of differences between these two categories. The first obvious difference is size and mass. Major planets are much bigger and more massive. They also have to be spherical, while dwarf planets might not be perfect spheres and might have weird shapes, like an egg-shaped Haumea, for example. And just like a regular planet, a dwarf planet orbits the Sun, but it doesn't have a clear orbit. Its orbit is full of debris and random objects. These are the only differences between the two. Well, as you can imagine, the reclassification sparked quite a controversy. People even made up a new term, Plutoed, which means downgraded. But although it might be sad that Pluto isn't a major planet anymore, we can look at it like a story about finding your true family. And finally, while standing on Pluto, you would see its 5 moons: Styx, Nix, Kerberos, Hydra, and the most mysterious one, Chiron, also pronounced Charon. So you can pronounce it however you like. I'm going to go with Charon. Now Charon is Pluto's largest moon. It was discovered in the 70s thanks to NASA's spacecraft called New Horizons. The spacecraft took a picture that revealed a moon with a strange and fascinating huge red-brown spot on its surface. It's a vast canyon dwarfing the Grand Canyon. It seems that both Pluto and its moon can boast interesting formations on their surface. The thing about Charon is that it's very big for a moon. It's about half the size of Pluto. This makes scientists wonder, could it be that Pluto is a double planet system? The center of mass, or barycenter, of Pluto and Charon lie outside of Pluto. Normally, with planets and their moons, the center of the planet itself should be the center of the mass, with the moon orbiting around it. But in the case of these two, it seems like they orbit each other. Binary objects are quite common in the universe. These cosmic pairs form just like our moon, from giant impact events. But double planets are exceedingly rare, and we haven't discovered any double dwarf planets yet. So, if it's true, then Charon is actually the 6th dwarf planet, and that would be our first binary dwarf planet system ever. There's also another candidate, the dwarf planet Eris and its moon Dysnomia. The solar system is full of mysterious and fascinating moons, so fascinating that some of them might not even have actual life on them. We've been talking about microscopic life in space for a while now. The debates about whether we found some organic fossils on Mars or not have been going on for decades. With the development of our technology, we're finally getting onto something. Meet Enceladus, who has stolen the spotlight since NASA's Cassini probe arrived there. Enceladus is covered in a sort of snowy blanket, which is why it's so unusually bright and has some snow-covered craters. It's small, only about 310 miles, and is mostly composed of simple rock and ice. But in 2004, we found plumes of water bursting out from this moon's south pole, which means that there's liquid water beneath this moon's icy surface. It's probably because of Saturn and its other larger moon, Dione. Their gravitational dance creates tidal forces that keeps Enceladus warm and lively. All this means that Enceladus is now a top candidate in the search for life within our solar system. Of course, life requires more than just water, and we won't find any animals there or anything like that. But we might find some microscopic organisms, and that's awesome too. In fact, Saturn is winning the lottery when it comes to life candidates. For example, scientists have a wild idea that Titan, another of its moons, might be home to extraterrestrial life as well. Titan is a frosty moon, chilling at about minus 290 degrees Fahrenheit. Surprisingly, it has some lakes on its surface. But don't imagine your typical water bodies. These lakes are believed to be filled not with water, but with liquid ethane or methane. Back in 2005, NASA discussed that there might be life munching on chemicals like acetylene or hydrogen in Titan's lakes. And then, in 2010, NASA investigated this moon some more. They found missing hydrogen and acetylene on Titan's surface, hinting at the possibility of something eating away at these substances. That's why some scientists dare to imagine methane-eating beings in Titan's freezing lakes. Moreover, they suggested that if these creatures exist, they probably have much larger cells than animals on Earth. What we could find there is something much bigger than a simple microbe, even something like a small animal. But Saturn isn't the only lucky one. Triton is Neptune's biggest moon. And you guessed it, it's another life candidate. It's an icy world with frozen nitrogen all over its surface and a crust made of water ice, again super chilly. However, Triton is a hotspot for geologists because it's one of just 5 moons in our solar system that likes to show off with its active geysers. It's shooting nitrogen gas up into space. That would be a cool show, if we could see that. These geysers mean that Triton has some secret source of warmth, which means that, just like with Enceladus, there might be some liquid water underground on Triton. And if this cozy spot for life does exist, we might find some organics there. Unfortunately, sending a mission to explore these celestial bodies isn't easy. The only spacecraft we've sent so far was our Voyager 2 in 1989. We need more time, money, and technology to develop spacecrafts that would be able to travel far and investigate the area beyond Mars. And even if we do, it'll take decades for this spacecraft to reach these places. In any case, let's hope that during the 21st century, we'll finally be able to fully explore our solar system and all its mysteries. Pluto, an ex-planet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first 500 million years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to -37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind: hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular: lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, far, far out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if two gas giants collided? I mean, the chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their two cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, two cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas.
Imagine leaving your house one morning and seeing not one, but two stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperatures suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long, long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. and we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, The methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the 5th planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles, between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular, or it may simply disappear.
It may seem like the best way to get to some planet from Earth is to patiently wait for it to come as close as possible. Yeah, there it is. And then take off on a rocket pointed in the planet's direction. Whoa, bye Mom, see ya. Wait, why didn't this method work? First off, the planets, including our own, constantly move following their elliptical orbits at speeds of tens of miles per second. So your rocket kinda needs to be put in an elliptical orbit, right? Kinda like aiming a dart at a moving target, or throwing a surprise party for your friend. You don't want the surprise to come at the wrong moment. Also, when we send spacecraft to other planets, we want to use as little energy as possible. And to get to any planet out there in the easiest way possible, you actually need a special trick called the Hohmann transfer orbit. Let's say you want to travel to Mars. You have to wait until Earth and the red planet are in the right positions, so you don't get lost up there or run out of fuel somewhere halfway. Traveling there using a Hohmann transfer orbit would take about 259 days. That's because the transfer orbit between Earth and Mars takes 517 days to complete a full orbit, and the trip to Mars covers half of that orbit. Couldn't you just travel faster? Well, yeah, but that would waste way more fuel, which would make the launch more complicated, since the rocket would be too heavy. Basically, it would be like a dog biting its own tail. If you could travel at the speed of light, it would take you 12.5 minutes. Also, when your rocket finally gets to the other planet, it still needs to slow down to go into orbit around it, or even land on its surface. This means it will use more energy. But you can try to use as little as possible and maybe go with things such as parachutes or aerodynamic braking. It's kind of like if you were riding your skateboard and needed to stop. You wouldn't just crash into a wall. You'd use your foot or something to slow down gradually. Traveling to Venus is a bit quicker. It would take you about 146 days. That's not bad. But the problem is you'd still need to wait for about 2 years before coming back to Earth. That's necessary because the planets need to realign themselves properly so that the spacecraft can meet Earth's orbit when it returns. So, in total, a round trip to Venus would take around 2 years and 1 month, including the waiting time. And that waiting time wouldn't be that pleasant, considering that's the hottest planet in our solar system. Let's say you want to travel to Jupiter. How long will that take? It depends on a lot of things, mainly its position. Plus, how fast are you traveling? If you want to use the best technology we have right now, you should know that it took the fastest spacecraft ever built, NASA's New Horizons, just over a year to reach Jupiter. But keep in mind that the New Horizons mission was just a flyby. The spacecraft didn't actually go into orbit around Jupiter. If you wanted to stay in orbit and explore Jupiter up close, it would take way longer. So, definitely not a weekend trip. Using the Hohmann transfer, you'd need several years to get to Jupiter. That's because a Hohmann transfer puts focus on transferring an object from one orbit to another. Jupiter is in a higher orbit than our home planet. So, to finish the transfer, your rocket would need to travel along a path that would take it past the orbit of our gas giant. So the rocket would need to speed up when it gets closer to Jupiter to avoid falling back towards the sun, and then slow down when it passes Jupiter to avoid flying off into space. It's like a car speeding up to climb a hill and then slowing down as it goes down the other side. This is how the spacecraft uses the gravity of Jupiter to move into orbit around the gas giant. It's hard to tell the exact distance between Jupiter and Earth. They're both traveling around the sun in different oval-shaped paths. Sometimes they get really close to each other, and other times they're really far apart. It's like they're playing tag. But on average, they're 444 million miles away from each other. When Jupiter is farthest away from Earth, it's a whopping 601 million miles away. That's like driving around the entire Earth 24,000 times. But if you could travel to Jupiter at the speed of light, on average, you'd get there in 40 minutes. There's this super fast spacecraft we need to mention, the Parker Solar Probe. Imagine you're on a really fast roller coaster, moving at incredible speeds that are hard to fathom. The roller coaster would actually be our Parker Solar Probe. It's flying closer and closer to the sun, breaking speed records along the way. During its 10th close flyby of the Sun in November 2021, the Parker Solar Probe managed to reach a top speed of more than 360,000 miles per hour. That's like traveling around the whole Earth in several minutes. And get this, when the spacecraft gets even closer to the Sun in December 2024, it's expected to reach a speed of 430,000 miles per hour. Yep, not a good idea to have a big lunch before this roller coaster. Now, let's say you're on the Parker Solar Probe and you want to take a detour to visit Jupiter. If you were able to travel in a straight line at the same speed the Parker Solar Probe was going during its 10th flyby, it would only take you 42 days to reach Jupiter at its closest approach. On their average distance, you'd need a little bit longer to get there, 51 days. You'd also have to consider the duration of your trip. There are two ways your rocket can arrive at a planet, either by going into orbit around the planet or by just flying by really fast. If the spacecraft is supposed to go into orbit, it needs to slow down when it gets close to the planet. Imagine it gets captured by the planet's gravity and starts going around it. Better to slow it down when it arrives then. And this means burning lots of extra fuel and making your trip longer. Here's something interesting. To travel faster, we can use something called gravity assist. That means we use the gravity of planets and other objects in space to give us a little push and speed our precious rocket up. That's how the Voyager spacecraft were able to travel to Saturn and beyond. But even with a gravity assist, it still takes a really long time to travel to other stars. For example, the star that's closest to us is Proxima Centauri, and it's still 4.2 light-years away. Let's change the method now compared to the previous examples. If we traveled at the same speed as Voyager 1, it would take us 75,000 years to get there. If you prefer to take a trip to Uranus, know that the distance goes up to 2 billion miles, depending on the spot where the planets are during their orbits. It took about 9.5 years for Voyager 2 to reach Uranus. But Uranus is cold, and as an ice giant, it doesn't even have a real surface to land on. Most of the planet is swirling fluids anyway. Not only would you have nowhere to land there, but your rocket would hardly even manage to pass through the atmosphere of Uranus unscathed. The temperatures and pressures are extreme up there and would just destroy your entire metal spacecraft.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our Sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands, like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens. but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Marsquakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight's seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight's seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian Dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian Dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, The wind is all wrong. It's hard to breathe. And there's no water in the ocean. Well, panic not. It's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us – sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild. Layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For waves to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels. But future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, The discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life. Well, it's official. There is life on Mars. No, it's not a clickbait. Let me break it down for you. Most people imagine extraterrestrial life as little green and preferably intelligent people. But we need to distinguish between life and intelligence. When someone tells you there's life on another planet, you probably immediately think about some smart being you can converse with. But life is something different. It's often associated with organic. And NASA's Curiosity rover has found the biggest organic molecules ever seen on the red planet. They were hiding in super old Martian rocks, and I mean about 3.7 billion years old. These kinds of molecules can be leftovers from stuff like fatty acids, which help build cell membranes. It may not be the life we're used to thinking of, but at the very least, the ingredients for what we call life have been there. So NASA's Curiosity rover has been cruising around a huge crater on Mars called Gale Crater. Scientists think this crater used to be a lake several billion years ago. The rover's main job is to find out if Mars ever had the right conditions for life. And one day, Curiosity drilled into a chunk of ancient mudstone in a spot called Cumberland. It collected some rock powder, and scientists ran a special test on it using a tricked-out oven built into the rover. That oven gets really hot, about 1500 degrees Fahrenheit. Luckily, the experiment's conditions allowed the researchers to cook off molecular oxygen, which limited the risk of combustion. And they found something surprising: chains of carbon atoms, up to 12 atoms long. You can find similar chains on Earth in everything from crude oil to, here we come again, living things. You may say that so far, the discovery doesn't sound too earth-shattering. But wait! Yep, these molecules can form naturally through non-living processes, like reactions with water, heat, and minerals. Hydrogen, carbon monoxide, heat, minerals — well, that's enough to cook up these molecules, even without biology. At the same time, such molecules are also common byproducts of life. Here on Earth, we produce similar compounds all the time, especially as carboxylic acids, which are everywhere in living organisms. So, even though these chains might have formed naturally, they could also be leftovers from something once alive. Maybe microbial life, maybe something way more complex. We just don't know yet. But the most unusual and intriguing thing about the molecules is that these carbon chains are pretty fragile. On Earth, sunlight, air, and water would break them down over time. Yet, they're still on Mars after billions of years. So, even if these molecules don't belong to Martian dinosaurs, we now know that the red planet is good at preserving organic stuff. And this is huge for the search for ancient life. There's a good chance that chemical traces of that life might still be hiding in the rocks, and apparently, Curiosity is capable of detecting them. Now, by the way, this is not the first time Curiosity has found organics. It's also picked up chlorinated organics, sulfur-containing stuff, and nitrates, basically ingredients that, if life ever brewed on Mars, would have been part of the recipe. Now, how about we talk about another hero sent to Mars to make incredible discoveries? Meet Perseverance. It's a car-sized robot NASA once sent far away from home to the inhospitable and dry red planet. In particular, to an ancient crater called Jezero. The Jet Propulsion Lab created Perseverance and prepared it for its first space journey, which started on July 30, 2020. For 7 dark, lonely months, the robot was traveling through the cosmos. Luckily, it managed to land on Mars safely on February 18, 2021. NASA even gave its landing spot a cool name, Octavia E. Butler Landing, after the famous science fiction writer. Since then, Perseverance has been busy exploring the red planet. As of April 8, 2025, it's been active for 1,469 Martian days, which are, by the way, called sols. That's about 1,510 Earth days, or a little over 4 years. The rover looks a lot like its older sibling, Curiosity, but it boasts some upgrades. It's literally loaded with tech: 7 scientific instruments, 19 cameras, and even 2 microphones to record sounds from Mars, like the wind or the crunch of the rover's wheels over rocks. Perseverance also brought along a tiny flying buddy. It's a mini helicopter named Ingenuity. Ingenuity made history by performing the first powered flight on another planet on April 19, 2021. It was only meant to fly a few times, but it kept going and made 72 flights in total. Unfortunately, on January 18, 2024, it got damaged during a rough landing, so NASA officially retired it. As for Perseverance, it has big goals. It's searching for signs that Mars once had life, especially in areas that used to have water. In its search, the rover is trying to figure out if the red planet even had the environments that could have supported life. It's also searching for past microbial life, collecting rock and soil samples to bring back to Earth one day, and testing out cool tech, like making oxygen from the Martian air to help prepare for future human missions. After landing in Jezero crater in 2021, Perseverance got to work right away, starting with its first campaign called Crater Floor. It drove south from its landing site and explored a spot called Saita. Then it returned to Crater Floor, Fractured Rough, and collected its first rock sample there. This was just the beginning of its exploration of Mars' history. In its second campaign, Fan Front, the rover made its way toward an ancient delta where a river used to flow into the crater. Perseverance climbed up a valley to check out higher ground, looking for more clues about the past of the red planet. The third and fourth campaigns, Upper Fan and Margin Unit, had the rover studying rocks that could tell us more about the planet's climate and whether it could have supported life. In December 2024, they started planning Perseverance's fifth campaign, Northern Rim. It's supposed to study the crater's rim where rocks from deep below the surface were blasted to the top during an impact billions of years ago. Perseverance has made some awesome discoveries so far. It found volcanic rocks on the crater floor that showed they interacted with water. This was a surprise, because scientists thought the rocks would mostly be sedimentary, not volcanic. At a place called Wildcat Ridge, the rover even found signs of an ancient lake that could have supported life. The rocks Perseverance has found are great at preserving potential signs of past life, so this is a really big find. The rover has also discovered some of the sediments in the delta were deposited by calm waters, but later massive floods brought large boulders into the crater. It means that Mars's climate must have been changing over time. Now, on top of that, Perseverance has done a few cool experiments. The MOXIE experiment managed to produce about 4 ounces of oxygen from the Martian atmosphere. It could be really helpful for future human missions. The rover also used its microphones to study sounds on Mars. It turned out that sound traveled more slowly there than on Earth. Plus, it was quieter on the red planet. The rover's Pixel tool analyzed rocks and found a bunch of minerals like ovoline, clays, and carbonates. This discovery showed that water had always played a big part in shaping Mars. The RIMFAX radar also helped the team see that the crater floor was made up of solid rock and volcanic material, and that the delta had formed in a calm lake-like environment. All in all, Perseverance has been giving us a much clearer picture of Mars's past. It's discovering evidence of volcanic activity, water, and environments that could have been suitable for life. It's also helping scientists gather crucial data for future missions. By studying the planet's geology, atmosphere, and potential for life, Perseverance is setting the stage for future exploration, and one day, maybe even for humans to walk on Mars. Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called Aurora Borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex whirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the Moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that.
Saturn is not the only planet with rings. Neptune, Uranus, and Jupiter have them too. Check this out. Even though Neptune is so far, we still got the clearest view of its rings over the past 30 years. And check out good old Uranus. It comes with 2 sets of rings. The inner system consists of 9 rings that are mostly dark gray and pretty narrow. There are 2 outer rings. The outermost one is blue, like one of Saturn's rings, while the innermost one is reddish, just like some dusty rings you'd find in other spots in our solar system. Jupiter's not bad either. Its rings are made up of small dust particles and are so faint that we can only see them when they get lit by the sun, or when we observe them directly in infrared light. There's an interesting story about how Jupiter got its rings. The dust the rings consist of formed when micrometeors, which are tiny pieces of rock and debris, hit the small moons around Jupiter. As expected, these impacts made a mess and threw up dust into space. Jupiter obviously saw its chance to get itself some nice rings, so it captured dust into its orbit. These particles of dust are really small because if the impacts were any bigger, gravity would pull the larger pieces back down to the surface of the moons. And these micrometeors keep hitting the moons and add more dust to these rings, so they always keep fresh and a bit new. Okay, cool story. But none of these planets have spectacular rings like Saturn. They're made up of small particles of ice, rock, and dust. And these pieces probably came from asteroids, comets, or moons that broke apart before they even got to Saturn because of its strong gravity. What makes Saturn's rings so special is that they're made of many tiny particles that reflect a lot of light. This is why they're visible, even with an average telescope that amateur astronomers use. When we look through the telescope, we can see the rings clearly because they're big and bright. And these chunks in the rings range in size from tiny dust grains to those as large as a house. And if we could look at those rings, we'd see some of the particles as big as entire mountains. Wow! Imagine if you could sit at the top of it and enjoy the roller coaster ride around Saturn. If you could look at the rings from the cloud tops of Saturn, they would mostly appear white. Plus, each of its rings moves at its own speed. Wow, stunning, right? But the news up there is not so good. It seems that these fascinating rings are disappearing. In fact, ever since the 1980s, Astronomers have known these rings are getting smaller as time goes by. It appears that the particles from the rings are actually raining down onto Saturn's atmosphere. Not just raining. Every day, an amount of water you'd find in an Olympic-sized swimming pool falls onto Saturn. But scientists are still not quite sure how quickly these rings are disappearing and when they will be completely gone. And to see this, we have NASA's James Webb Space Telescope, JWST, and the Keck Observatory in Hawaii that will study Saturn over a long period of time. They will track what exactly happens with this ring rain and how it changes during one full season on Saturn. That's about 7 Earth years. And a lot of ring material is falling onto Saturn all the time. Somewhere between 880 and 6,000 pounds of icy rain flows onto the gas giant every second. And by this, it's heating up its upper atmosphere. If this keeps happening at the same rate, Saturn's rings might disappear in about 300 million years. Hope humankind will get at least one roller coaster ride before they're gone, though. But while this may seem long to us, in terms of space, it's relatively quick. But this rate could slow down through time, so the rings might be there for more than 1 billion years. Or, if they start disappearing faster, about 100 million years. It's not like this process happens by itself. Space rocks and the radiation coming from our sun affect all those particles in the rings. They give the particles an electrical charge. This charge causes them to stick to Saturn's magnetic field lines. Saturn's mighty gravity then pulls these icy particles in, and they flow into its upper atmosphere. Saturn goes around the sun once every 29.5 years. As it's making its circle, it moves closer to and farther away from the sun, and its rings do the same. This tilt affects how much the sun's radiation affects the deepest layers of the planet's rings, which is where most of the icy rain comes from. Scientists think that when the rings are tilted to face the sun, there will be more material falling onto Saturn. But when the rings are edge-on with the sun, the material falling onto Saturn slows down. Scientists are not only trying to predict the fate of Saturn's rings, but they also still debate when and how they even formed. Some theories say the rings have been around ever since our solar system formed billions of years ago. But the Cassini spacecraft explored Saturn and brought some data that encouraged the idea that the rings are way younger than that, maybe 10 million to 100 million years old. Another interesting idea says the heavy rain from the rings might make them look younger than they actually are. Whoa, did those rings find their own fountain of youth? But I'm afraid not even that can make the rings last forever. Sooner or later, Saturn will have to face an identity crisis when it loses its beautiful rings. At some point, it seemed this year wasn't so good for Saturn, because another one of the planets was quickly heading to take the title of the one with the largest number of satellites. In February of 2023, scientists discovered 12 new Jupiter moons, and Jupiter overtook Saturn to become the leader in the number of moons. These moons accidentally popped out while they were looking for Planet 9. You know, that one hypothetical planet that could be lurking somewhere in the outer region of our solar system. And these newly found moons are kinda dim and small, but they couldn't hide from our powerful telescope and the advanced techniques scientists use to spot them. What's interesting is that 9 of the new moons orbit Jupiter in the opposite direction of its rotation, while the other 3 orbit in the same direction. What happened to those fellas? Do they even know they got into the wrong lane? Some say they could be the remains of bigger bodies that broke apart after hitting some other objects. So typical for space. Now, there's a moon called Valetudo that was discovered a few years ago. Unlike the retrograde moons, Valetudo has a prograde orbit, which means it orbits in the same direction as Jupiter's rotation. What's interesting is that Valetudo moves in an orbit that crosses into the paths of these retrograde moons. Could it be the retrograde moons formed because they collided with prograde moons such as Valetudo at some point? Hopefully, we'll find out. It was a great success for Jupiter, but 3 months later, things changed when they also found 62 satellites circling around Saturn, which means Saturn became the leader again, with 145 moons in total, compared to only 95 of Jupiter's moons. Astronomers have discovered new moons around Saturn using a technique called shift and stack. This means they combined multiple images that shift along with the moon's movement, and this helps to enhance the faint signal from the moon. That's how they discovered even those smaller and dimmer moons they couldn't have previously seen in single images, like those that are 1.6 miles in diameter. They needed to confirm these objects were moons and not some asteroids passing by, so they tracked them for a couple of years to see their orbits around Saturn. So, Saturn may be losing its rings, but there are more moons over there than expected, and who knows how many more interesting things we'll find around it. Prepare for blastoff, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25th, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide and seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor. Literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are two possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called Aurora Borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E ring. It's made up of ice grains in Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri B. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri B is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri B isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.